All right. First and foremost, thank you everyone for attending today. And today is another Chill Skills Sporlan Tech Talk. And today we are going to focus on how to adjust TEVs for superheat. Now, before we get started, I just want to talk about the upcoming Sporlan Tech Talks that we have. Every single month, we're going to be hosting one of these. In July, we're going to talk about how to identify a TEV. That's going to be great for everyone on the counter, for salesmen, for contractors. That's going to be a good one. In August, we'll talk about everyone's favorite product, which is ZoomLock. In September, we'll go into operation and selection of solenoid valves. And then if you do have any suggestions for further tech talks, please leave a comment. And if you haven't used Zoom before, you should have both a chat function and questions and answers that you can use throughout the presentation. All right, please note if you do not have sound via your computer, we do have a dial-in that should have been included in the invitation via email. Please mute your microphones. I don't think anyone's unmuted. It's pretty quiet here. If you do have questions, use that chat window or the questions and answers. And this webinar is being recorded. All right, first and foremost, I want to introduce myself. My name is Henry Papa. I am the Sporlan sales engineer out of Florida. And if you have any follow-up questions or if you have anything that you'd like me to follow up on, my email address is henry.papa, P-A-P-A, at parker, P-A-R-K-E-R.com. Okay, so to obtain optimum performance with a thermostatic expansion valve, a TEV, TXV, on either refrigeration or air conditioning systems, superheat is going to be important. It must be checked after installation on initial startup and adjusted as necessary. So throughout this training module, we're going to talk about the appropriate superheat settings and the steps needed to properly adjust Sporlan TEVs to meet those desired superheat. Okay, so these are the topics we're going to cover. You're going to first learn how to identify if a valve is externally adjustable or it's an OEM valve that's non-adjustable. We'll talk about the reasons why it's necessary to check superheat. And then we'll go into the actual steps to make the superheat adjustments. All right, so as most of you know, thermostatic expansion valves, the mechanical thermostatic expansion valves, are the most widely used type of mechanical metering device in refrigeration and air conditioning systems. While most OEMs use non-adjustable or factory preset valves, a lot of the valves that you'll see in the aftermarket are externally adjustable. And that way they could be fine-tuned for peak performance. Now, most Sporlan authorized wholesalers, all the valves they're typically going to sell are adjustable. Okay. The easiest way to determine if a valve is adjustable or non-adjustable is part of the nomenclature. Okay. If the valve is stamped with an N on it, that means it is non-adjustable. So for example, a valve like a NSVE-5, that will be non-adjustable. Okay. Another good way to tell is just by looking at it. On the slide right here, you can see visually the difference between an adjustable and non-adjustable expansion valve. The adjustable valve, you can see, has two wrench flats. It's going to have a bottom cap and the adjustment stem steel cap. And you'll see that it's conical at the bottom. And while you'll notice on the non-adjustable valve body, there's only one wrench flat for the bottom cap. One of the worst things you can do is to try to determine if a valve is adjustable by removing that bottom cap. If you're unsure, please consult with Sporlan. Please check our bulletins. Okay, and we do have a question here from Michael. Can a non-adjustable valve be converted to adjustable? And yes, they can. We're going to talk about that later in the presentation. So that's a good question. All right. So yes, non-adjustable valves are common coming from the OEM in the factory. However, we do offer adjustment stem assembly kits to convert these non-adjustable valves to externally adjustable. Okay. And this may be important, especially when doing refrigerant retrofits. And we'll show you down later in the presentation, we do have a bulletin that addresses the actual part numbers that we use to convert the non-adjustable valves to adjustable. Okay, so before a system leaves a factory, a specific superheat setting is typically made on each expansion valve. And while the standard setting is good for different capacities and different charges, with a system in different environments and different load conditions, you may need to make adjustments. And so the first thing we want to do is determine superheat. Now, remember the main reason we have these TEVs, the thermostatic expansion valves, is to control superheat at the bulb location, typically right after the evaporator. And we're doing that for two main reasons. Okay, so what's happening inside of your evaporator is the refrigerant is boiling off. Okay, and superheat is telling us that we have boiled all of the liquid refrigerant before getting back to our compressor suction. Okay, so this is going to accomplish two things. We're going to protect our compressor from lubricant washout, and we're also using our evaporator coil as efficiently as possible. So I have a question here from Russ in the chat, which is what is actually being adjusted inside of the TXV? And actually, in a couple slides, we'll have a cutaway to show you when we do make the adjustments, what's happening to change the superheat. Now, that's a great question. Okay, so for those of you unfamiliar with measuring superheat, how do we make that calculation? So we're going to need two items of information. Number one is going to be our suction line temperature. Okay. Second is going to be our suction line pressure. Now, from our suction line pressure, this is when we're going to use our PT charts or Sporlan's app. We have a great PT chart app. It's called Chillmaster PT. You can simply search Sporlan on the App Store or the Google Play Store or the Android Store, and it should come up. And that will have virtually every single refrigerant you need. And so what you're doing with these PT charts is finding the boiling point of refrigerants. So when you find your suction pressure, you correlate that to a temperature, and that's what temperature your refrigerant is boiling in your evaporator. So in this example here, we have 410A. From our temperature probe, we actually have a line temperature of 52 degrees. Okay. From our gauges, we can find our suction pressure of 119 psig. We would take that 119 psig and either plug that into our Chillmaster PT app or use our PT charts to find that the boiling temperature of 410A at 119 pounds is 40 degrees Fahrenheit. And then to find our superheat, we just have to subtract that 40 from 52 degrees, giving us 12 degrees of superheat. Now, one of the things I want to address that I don't have in this presentation is for refrigerants with Glide, a refrigerant blend. There's some misconception about what temperature to use when calculating your saturated suction temperature, which is the temperature you're getting from your PT chart. And you want to use the dew point. The dew point is going to be the boiling point of that blended refrigerant at that specific pressure. And so for me, it sounds really cheesy, but the way I remember it is the rhyme Sue dew. So when you're measuring Sue per heat, you're using your dew point. So Sue dew. Hopefully you guys actually use that. All right, so now that we've read superheat, how do we know if it's accurate, if it's what's expected? And that's why we want to first suggest following your OEM manufacturer guidelines for superheat. If that is unavailable, then you can use our recommended guidelines for superheat. Now, for applications with a high TD, meaning a high differential between the return air the discharge air and your evaporator temperature, we want to have a superheat of around 8 to 12 degrees. Now, when it gets to commercial refrigeration, also known as medium temp, around 6 to 8 degrees of superheat. And for low temp, 4 to 6 degrees of superheat. When your superheat starts to fall out of that range, that's when we risk either flooding back to our compressor or we're not using our evaporator coils as efficiently as possible. And that's when we want to think about making an adjustment to our superheat. Okay, so after we've measured superheat, next thing we want to do is just some general guidelines. We want to make sure our load is at or near our design operating temperatures. Okay? And for refrigeration applications, there are some additional concerns. First, we want to make sure we have a consistent saturated condensing temperature, a consistent head temperature. And second, we should make sure our evaporator is clear of any frost. Okay. And these are the tools we're going to use to make these adjustments. Sporlan does offer this, it's a flat tool on the left here. It has two different square sizes for different stems, and it does have this spanner wrench to loosen any packing nuts. A lot of Sporlan authorized wholesalers do offer these refrigerant ratchets as well, which can be used. The reason I prefer the Sporlan tool is because number one, it is more compact. So a lot of small spaces like a reach-in, like a case, you might not have the room to use these refrigerant ratchets. So these tools come in handy. And on top of that, we want to make sure we're adjusting our adjustment stems in small increments. And with the Sporlan tool, you can actually keep track of how much you have adjusted the stem versus these ratchet tools, which are hard to see how much change you've actually made. Okay, so the second step we're going to do is remove the seal cap. You could do this by using two adjustable wrenches, using one to hold the valve body still while loosening that seal cap. Next, on the valves that do have a packing nut, we do want to use a spanner wrench to loosen the nut. And we're going to do that by turning it counterclockwise, but no more than one full turn. And that's to prevent damaging any of the packing seal during the adjustment. Okay, and next is going to be our fine tuning. Now, to decrease superheat, we're going to turn the stem counterclockwise. To increase the superheat, we're turning it clockwise. And I'm going to say this more and more times, only adjust about a quarter turn at a time. Now, Russ, this is where your question comes into play. Now, when we want to lower superheat, what are we doing? We're adding more refrigerant into our evaporator coils. And how we do that is adjusting the adjustment stem. When we are going to do that counterclockwise. When we turn the adjustment stem counterclockwise, we're putting less tension on the spring that you can see. Let me see if I can highlight that here. Can you see my mouse? That spring here, when we adjust counterclockwise with the stem facing us, that's going to put less tension on that spring. When we have less tension on that spring, it essentially makes it easier for refrigerant to get through our expansion valve into our evaporator coils. So then we get more refrigerant. It takes less, or excuse me, then it would take more of our evaporator surface area to absorb the heat and boil off all of the liquid refrigerant. Does that answer your question? Awesome. Okay, so remember when we're adjusting, again, about a quarter of a turn at a time. Okay, now in opposition, if we want to raise superheat, we are going to turn the valve stem, the adjustment stem, clockwise. And this is going to put more tension, making it harder for refrigerant to get into our evaporator coil. And that means less refrigerant, which means the liquid will boil off before. That means the refrigerant will pick up more sensible heat and you'll have a higher superheat. So it's kind of like a inverse relationship. If you want to raise superheat, you want less refrigerant in your evaporator coils and vice versa. Okay, now after we've made any adjustments, we want to make sure we're giving the system time. Because again, what's happening is we're changing the amount of refrigerant inside of our evaporator coils. That's going to change the temperature that our sensing bulb is seeing, which will change the amount of pressure on the diaphragm in the power head. So it just becomes a cycle that is changing and changing. So we want to give our system time, at least 15 to 30 minutes to adjust before measuring superheat again and making any adjustments. Okay, so this is going to be related to the question that we got from Michael, is can we make non-adjustable expansion valves adjustable? So if you want to do this, you'll see in the leftmost column, the adjustment assemblies. That is the part you will order from a Sporlan authorized wholesaler. And that is going to be the kit you need to convert from non-adjustable to adjustable. Okay, and this is a chart that you'll see in our Sporlan Quick Tips. It's Form 5-220. And this is a great tool to have, especially for the techs out there that are making adjustments to superheat. Okay, it's very important to know how many turns you have total inside of your valve. Okay, so if you are a tech and you're making adjustments to an expansion valve and you can't get your superheat fine-tuned, you're not sure where you are in the valve, an easy thing to do is figure out how many turns total you have and just go back midway. Midway in those turns is going to be a factory setting. So for instance, if you don't have this chart, what you can do is turn your adjustment stem all the way closed, then open it back up all the way and count how many full turns you have. Okay, so for example, if we have a valve that we close off and open all the way and we count 20 turns total. If we close it back 10 turns, that's a Sporlan factory setting. And it's a good point to take your time, let your system equilibrate, then you can start making your adjustments again. And again, a quarter turn at a time, giving it time to adjust. Okay. And while we're talking about adjustment, one of the most common issues that I've seen with expansion valves that quote unquote go wrong is an adjustment stem that's been forced closed or forced open. Once you're adjusting your adjustment stem and it is firm and you feel like you've bottomed out, please do not force it anywhere past that. It's very easy to strip the threads on the adjustment stem. And once that happens, you have to replace the whole valve body. So it's best to just stop where you feel it snug and do not continue past that. And it looks like I missed a question here from Russ. So Russ's question is approximately how many BTUs are being added or taken away per turn with the spanner tool? Unfortunately, Russ, that's a question that we do not have a correct answer to. That will depend on each valve and each application specifically. So we do not have a answer that will answer that for every single valve and every single system. That is a good question, though. Okay, we've talked about this a couple times throughout the presentation, allowing your system time. And after that time, once your superheat has stabilized, then we want to go ahead and repeat the process, making additional adjustments as needed. Okay, and once our superheat is within the range that we would like it to be, now we're going to go ahead and retighten our packing nut if we do have one. We'll reinstall and tighten the seal cap. And that should be all. Once that happens, we should be good to go. So the key takeaways is refrain from adjusting more than a quarter turn at a time. Allow the system to adapt to its new settings. And whenever it's possible, follow your OEM's recommendations. And if not, then you can start following our recommendations. We do have our technical support line, 636-392-3910. Or again, you can feel free to reach out to your local Sporlan rep or me as well. Okay, any more questions? That is all we have in this presentation. So we had some good questions. And again, we do have another great tech talk coming up next month, which is how to identify TEVs. That seems to be a really good talk, especially now in the summertime when a lot of techs are replacing expansion valves. Yeah, and thank you, Russ. Thank you for your attendance. Okay, well, if there are no further questions, that sums up the presentation for today. Again, thank you for your time, and we'll catch you in the next one.